Hello, Google fans, and welcome back to our Passport to Containers series, coming to you today from Atlanta, Georgia, the 6th location in this series, and we're going to be talking about one of my favorite topics. We're going to be talking about demystifying Gen AI inference on the Google Kubernetes engine. Without further ado, two of the most fantastic people on the planet to talk about this. Poonam and Eddie, thank you so much for coming to hang out.
Thank you. We're
Thank
super
you for
excited.
having us.
Yeah.
It's been a journey. I'm really glad you could make it, especially with flight challenges and everything else today. It's so great to show off some of the other offices, some of the rest of the team around the country, and
It's
not.
a beautiful view. It's a great site.
Yeah. This is one of my favorite sets. I think this might be one of our favorite sets ever, at least for me. I don't know about Ken. Let's get the ball rolling by talking a little bit about your background, how you ended up in Kubernetes. But before we even get there, I want to know, Bobby and I talk about this a lot, what made you fall in love with tech? Poonam, I'll start with you.
Well, that's a great question. I liked math and science, and I did not think that I'm going to end up becoming a computer engineer until high school. And that's when
That's still pretty early, for the record. You had a lot figured out. I was going to say, I don't think I had any idea what I was
Way
going to
ahead
do
of
back then. Yeah.
Well, before that, it was astronaut. I wanted to join the army, do different things. But then I met somebody who was going through computer engineering, talked to this person. They inspired me. I went ahead and applied to this school that I really, really liked. I got in, and that's how I ended up in tech.
That's awesome. What school was that?
It's Army Institute of Technology. That's the only school I wanted to go to if I wanted to do engineering.
Yeah.
So.
I love that.
That is cool.
That is cool. Eddie, what about you? When did you fall in love with tech?
A very circuitous route. I much later. So I was full on. I wanted to be in the military. I went to the Air Force after high school.
Thank you for your service.
Thank you.
Yeah.
Did nothing with computers as a career, but my dad had always had, he's a techie guy at heart, so we had Commodore 64s and 128s, and I was always on the computer at some point in time through my youth. So I was always around it, and then I decided that something I wanted to do when I was still in the military, so I got my degree in computer science while I was still in, and then when I got out, I was like, well, I can be an air traffic controller, or I can do this, and at the time I just like, you know what, I really want to do something in technology, and that's how I started the process. But yeah, it's like my second career, I guess, for lack of a better term.
Wow. Okay. So you might have been controlling the plane that got us all here versus.
Yeah. No. Gosh. Yeah. That's when it was.
Isn't it wild the different lives we could have lived? I mean, just pondering that.
Absolutely. Yeah.
Well, you'd be just as in demand as a technologist and an air traffic controller in this day and age, and
right.
everything that's going on. So how does this lead y'all to Kubernetes and AI within the technology world? Poonam, I'll start with you again.
Yeah. So, I started as an engineer building applications and eventually platforms for a large bank. And the technology goes through a whole bunch of evolution. So you may be writing a piece of code and you may be running it on your own CPU, and you then run it into a virtual machine, and then there was this whole phase of platform as a service, and you write code in those all of those evolution of software. And eventually 7 or 8 years back, I was working on evaluating Istio, the service mesh for organization, and that was the first time I actually got my hands on Kubernetes and really, really loved it. And since then, I've worked on different areas of Kubernetes, including being part of team which was building a private cloud for the bank, using Kubernetes. And then I joined Google and ended up in the GKE team, so more Kubernetes, I guess. Yeah, that's how I ended up working on Kubernetes. But I do want to say that at a fundamental level, if you really internalize the engineering principles and you're comfortable, building code, and then you understand how to run that code at scale for a critical business, I think the evolution that we go through is just easier. It's just understanding how things will change as you move from one platform to the other. But the underlying, the principles for software engineering, they more or less stay the same. And I think we're going to talk more about that
Yes, we absolutely are. But that makes a lot of sense. So you were outside of the Google Kubernetes engine and have been absorbed into the fold. I'm not surprised. I love that. I can see why. What about you, Eddie? How'd you end up in Kubernetes land?
Yeah, that's a good question. So my background has always been in like building data center, very complicated organization environments, and looking at it from a distributed nature, right? You know, building very large scale applications. And I was working for another cloud vendor at the time when like this thing called Docker came about, and I was like, okay, I need to investigate this a little bit further, and then the quick evolution from there to Kubernetes, and then I kind of went in like literally head first. I just like, okay, I want to start contributing. I want to be on the release teams. I want to know everything there is about it. And then at the same time, I got very lucky. A mentor of mine who was working with me at the cloud provider I was in. He was at Google before, and he was actually one of the co-creators of originally Kubernetes from Borg. He's in the papers and everything about it. So he and I, you know, he kind of brought me under his wing. We co-wrote Kubernetes best practices from O'Reilly Press together, and a couple other peers of mine. So I gained a lot of experience very quickly from the people that kind of established Kubernetes as the de facto container platform, and I was very blessed at that. You know, like how quickly can you ramp up to something so complicated unless you learn it from some of the people that made it, right?
What a wonderful experience for you,
sure.
Honestly.
And then coming to Google was like, I just got to go back to it was born, and then meet the rest of the team that did an amazing job, and a lot of them thankfully are still here, and it's really been a pleasure for sure.
Yeah, it has been, and you just talked about an interesting story with how this has become so ubiquitous.
Yeah.
And I feel like I got into the Kubernetes world 5 years ago, a little bit more than that, and there was still this toggle between Docker, other tools. Are we building on Kubernetes? What are we doing with containerization? And how are we deploying this? And what's it going to do at scale? And I feel like we've really tipped over in the last 18 months or so, where it feels like if you're building and you're thinking particularly about AI at scale, it's Kubernetes.
Yeah.
And it's cool. I mean, you made that bet a while ago, and it's come together for you.
I think the bet was one of those things that a lot of organizations had to kind of do a leap of faith. But
Totally.
But the principles were sound, right? I think
and a leap of complexity in a lot of circumstances, frankly.
Yeah. But it solved a lot of the problems that organizations were kind of faced with at the time. And now, if you think about AI, you know, I hate to kind of say like AI is just another workload. It is a workload, but specialized, right? And if you think about it, and then there's obviously a couple different sides of AI, but when we want to talk about serving, inferencing, where the end users actually use the product.
Yeah.
I think that's where we start seeing how Kubernetes really fits that really well. Yeah.
Let's unpack that a little bit, because we're headed there anyways. Inference, a term I don't think we're hearing enough, quite frankly, but the thing that really makes AI real and for the rest of us in that experience. But it is, I mean, it really is just another containerized serving workload. Talk to me about that, Poonam.
So let's ground ourselves in the real life example. I am going to school, so I'm going to pick that example.
Perfect.
Let's say there is a student named Alex. They go to school, they read books, practicing quizzes, you know, papers, and that means they are consuming a lot of data and a lot of information. And you can compare it to, you know, how AI models are trained roughly. And then one of these days, you know, Alex has to go and write this exam, and, you know, they get a question which is not something that they had seen before. So now Alex is not going to run and, you know, hit more books or, you know, go back to school. They are actually going to use the knowledge that they have gained through, you know, training themselves. And they will use that, and they will answer that question. And you can think of it as inference. And now let's map it to a system that you would build to do the same job.
Right.
Let's say you have trained a model. Now, you know, you will take that model, the configuration that you need to run that model, the libraries, the runtime environment like TensorFlow or PyTorch or JAX. You will package all of these things into a container. And now this becomes a portable unit that you will take from your testing to production. And now if you are a application developer who has worked on Python or Java or any other language, you're already thinking that that's exactly what I do when I'm building any web application. So I want to say it is not different. It is, there are, of course, some differences. It could be large and you could have to do model compression, it uses accelerators and all of those things. But at the foundational level, the core concepts still stay the same. It's an application which has been trained, and now you're getting some requests, with some new data that you may or may not have been trained on, and then you're getting a response back. So in a nutshell, that is inference. And it is very similar to the applications that we've been writing in regular web app or microservices world.
Yeah, I love that you used it. I love the analogy of a human learning, because I think we're very much in a space where we're separating humans and machines, and it's getting a little blurry and a little weird, but it is just like us learning and having the ability to critically reason in the moment and do whatever's supposed to happen next, whether that's answer that question or do anything else. So you talked a bit about these unique workloads. You talked also about how GKE makes these a bit easier.
Sure.
How does it do that?
Well, I mean, I think based on speaking of like what Poonam was talking about, where it's a workload, right?
Yeah.
With special needs, right? So if you think about
why are those needs so special?
Yeah, because at this point now we're talking about special chips that accelerators, the GPUs, TPUs that are so popular nowadays. And in the news, it's important to have those for the LM to reason, because that's the way they process and that's how they're built on, the architecture they're built on. So I'm going to follow my other mentor Bobby in his food analogies, right? Think
yes.
Of it. Yeah. So
our favorite part of every show.
I never worked in the food service industry, but I'm obsessed with the show The Bear, and fine dining restaurants and how that works. But if you think about like GKE, when you go to a restaurant, even fine dining restaurants, they take in orders. That kitchen has to be able to create a basic bisque all the way to like the most complicated beef Wellington, right? So if you think about what GKE is, this is very complicated, very organized kitchen that has all the equipment you need. But when I need to create that beef Wellington, I can. When I need to create just a bunch of salad, I can. So when I need to just serve web services, easy. GKE was already built for that. Now, with all those primitives and the APIs that we built upon that, the accelerator is just another resource, right? And it's another API. So now Kubernetes was always good at assigning resources to your compute, memory and CPU. Now this is just another resource that we optimize for that workload, right? So it's the same kind of concept, right?
Yeah, you're already poised to do it, essentially.
That's right.
Yeah. Oh man, that food analogy is so good. That's definitely making our next food highlight reel. But I think that's absolutely it, right? I mean, developers, creators, they're builders, they're chefs. They want to be able to do stuff, and it's this. I love this term that came up in one of our other segments. This optional complexity. And just the notion of that is kind of nice. Sometimes you do want to be able to adjust or see or do everything, and sometimes you don't. Right. Sometimes you just want it to work. Right. So let's talk a little bit about custom compute class and DWS Quickstart. Yeah. Break those down. Well, I'm going to start, Eddie, and then
I'll continue the thread.
Right? Yes, so you're already there.
Yeah,
so take us home.
Yeah, I think like on the same, following on that thread of like a very high-end restaurant and kitchen staff, right? You're going to have some very high-end equipment in that kitchen, and you're going to be able to, but at some time, like, hey, if my salamander broke, I think there's something called a salamander.
There is,
yeah, or a sous vide. If that broke, it heats things, right?
Yeah,
that's how you make great steaks, right?
Yeah.
If that broke, what does the chef say? Sorry, you can't have your steak today.
Yeah, woof.
No, it's going to happen, right? So if you think about what a custom compute class does, the custom compute class for us is a way for you as a customer to say, I need capacity, I need something, I need to get cooking, and I need it at the time I need it. And this guarantees that something will be available to you. It could be either in a smaller CPU or a smaller GPU size, or a different GPU size, or a different way to acquire that GPU. But either way, what we're trying to make sure is that the customer, especially for inferencing workloads, or I call them serving workloads because you're serving up something, you're giving
appropriate for the restaurant as well.
That's right.
You're really killing it. You're just dotting your eyes and crossing your T's on that one.
Yeah. So when I'm serving up something, I'm hitting an end user, and I need to make their experience happy, right? So I need to make sure that those resources that needs are available at all times. So custom compute classes are a way for our customers to get the capacity they need when they need it, in the most in a priority order that they decide, but also sometimes in the most equitable fashion. It's like, hey, I want to go to what I've reserved, or maybe I can fall into Spot, which is cheaper, but it's not always there if I don't need it, but it's okay for a bursty workload or something of that nature. So that's what our custom compute class does, and mixed with we have a new flavor of consumption called Dynamic Workload Scheduler, DWS. So CCC will allow me to kind of say I want on-demand, then DWS, then Spot, and let that process fail over. So the chef can say, let's put this on a sous vide, let's put this on the salamander, and let's move it around, and let's get what we need from where we get it. And that's how it kind of works.
Well, and this is unique because, first of all, running an accelerator 24/7 is super expensive. Can be very hard to have the right power needs at the right time. And usage is bursty. It's not like everything's getting executed consistently. So how does the GKE Inference Gateway help with that, Poonam?
So, traditionally when you run a web application, you have a load balancer. But these load balancers were designed for homogeneous load and and stateless sort of routing of the requests that are coming in. Which is very different from, when you're serving the AI requests, like inference requests coming in, because that could be bursty. You may have different sort of requirements where, you have a chatbot which is needing millisecond or sub-second response, versus you have a batch inference, which is maybe you can wait for a response to come back.
Right.
So Inference Gateway, it is open source, but we have a managed version of Inference Gateway through GKE as well. It's model aware, and it is accelerator aware. And let's break it down.
Yeah, I was just going to say, what does LLM aware mean for load balancer? Yeah, let's go.
Yeah, so what it does is, when you are sending request to Inference Gateway, you can specify the model name. And if you have different models, or you have multiple versions of the same model, you can specify all of that in the request body. You can also specify if the incoming request is critical, standard,
prioritization a bit,
something that you can drop. So depending on all that data, Inference Gateway can make a decision to route your request. But there's more. It is also collecting real-time metrics from the KV cache utilization, and also the queuing that is happening at model server level. So it uses all of those real-time metrics, and then it is integrated with HPA, which is horizontal pod autoscaler. So it can then scale your workloads up in case of a bursty request, or scale it down when there are no requests coming in. So in a way, most of our customers that we meet with, they are looking for faster, better, cheaper ways of serving inference, and Inference Gateway actually helps you do that.
I mean, it makes a lot of sense, and it's really critical. I can imagine the feedback from your community is positive, yeah?
Yeah, it's been great. I think the concept is, this whole idea of the transformer model, and how the transformer, which is kind of the generation of what most of these LLMs are based on, and it has brought that complexity, and then making it simpler for our customers and our end users to understand, how do we optimize for the way that this resource uses different things, right? And really saying, let's perform at the best level. And that's when we said, well, okay, now I can save money, and I can save resources and scale when I need it, and that's great.
And it sounds like accelerate time to value.
Absolutely.
If you're able to do everything more efficiently, you can probably do more experiments, you can probably test different things, build faster.
And that's our goal. Our goal is to get customers to be faster to market, because this is a fast race. And so how do we get them faster to market? And then once they're in there, how do we make sure that they can accelerate very quickly and at the most optimal and performant way?
Given the scale of companies that y'all work with, I would imagine you have some playbooks or some Quickstart guides that can help people, and dashboards out of the box.
Funny you mentioned that. Yeah, actually.
Tell me about those.
Yeah, so we launched it next in preview, something called our Inference Quickstart. And basically what we're doing is we're leveraging the power of our DeepMind, our partnership with DeepMind, and making sure that they're constantly doing benchmark tests on some of these larger open source models. The Gemmas, the Qwens, the Llamas, the DeepSeeks, and we're looking at them across our hardware fleet and getting these metrics. And then we're looking at very specific things that matter to customers that are serving generative AI workloads. So an example would be, how fast does that bot get an answer to me after I hit enter, right? We call that time to first token. It's a very important metric. And then there's, okay, then if I just get like one word back and then I have to wait an hour before the rest of the stuff comes out, that is not a bad experience. So then there's time per output token, TPOT. And so we have this metric called normalized TPOT, which basically says, like, this is what the overall kind of experience the user would have on getting a response back from the serving model. And so what we've done is we've kind of cemented ourselves on, like, let's look at, if a customer wants to dial in, like, hey, I'm an AI engineer, we're about to serve an application, I tell my platform engineer, hey, we're looking for at least 42 millisecond total round trip. Like, that's what we're aiming for, right? So we basically give them a little slider or CLI and say, hey, I need this much. And we'll tell you, hey, what accelerator you should be using.
Nice.
And what generation, what model. And then from there, so you give us the model, you give us the performance metric you're looking for, and then from there we'll give you what accelerator you should do. And then we went one step further. We said, hey, guess what? We'll give you a Kubernetes YAML manifest that is already pre-configured with all the right parameters for your deployment, also for your HPA, for your metrics and monitoring.
It's a big deal for getting up and off the ground.
Yeah, so think of it like, again, I don't want to go back to the food, but
always go back to the food.
Let's go back to the food.
Always go back to the food.
It's like, imagine having, my wife and I were, at one point, we're just so busy, we started doing like those take-home meal kits, you know? Imagine having like the highest end restaurant, Nobu, sending me, these meal kits, right? I go. So a meal kit at home, right? Yeah. But it's a quick start. I don't have to worry about figuring out like what's the recipe, what do I need, what do I have? It's all there for me, and then I can tweak it if I need to afterwards for my flavor, for my taste. That's basically what the Inference Quickstart will do for our platform teams and our AI engineering teams for our customers.
So I really love this. The audience is probably not familiar with this, but I know Bobby is. So my mother has been following along with the food analogies, and our food sizzle reel and this Food Lover's Guide to AI that I just wrote recently. And it has been, hi Mom, by the way, it has been such a beautiful bridge for us to be able to talk about all of this stuff because, first of all, I mean, all good people like food, let's be honest, and or at least you're not probably in my friend group. But it allows us to digest these very complex concepts in a way that is palatable and also easy to wrap our minds around, in the same way your analogy about the student and being a student did. And I think that's actually a big part of our job as leaders and shepherds of this technological revolution, is to make sure that everyone can understand. So never be bashful in the food. I absolutely love it. What about networking and storage? Why is this important for inference? Poonam, I'll ask you.
Inference workloads can be bigger. And it can be really chatty. You can have a lot of requests coming in, and that is why networking is important. And there is a lot of innovation that is happening in that space, including Inference Gateway that squarely sits into the networking space as well. Storage is another area which it wasn't cool until the
Okay, a lot of this stuff that we do wasn't cool until a couple years ago. I'm just gonna be really honest. Nerds are having a moment. Right now, it has never been cooler to be us than it is, and I'm here for it. I'm living for this moment.
So for this week, I'm actually a PM for one of the storage products. It's called as Managed Luster. We just launched it on 7th of July. So
oh my goodness, congrats.
Thank you. And what it does is it's a parallel store, which gives you, speed and scale that you need to run, petabytes worth of data that you need to train your training workloads or HPA workloads or things like that, or large-scale inference that you want to serve. So I'm just giving you one example, but there is a lot of innovation that is happening in the storage space. for KV cache, for checkpoints, for how you want to retrieve and store all this data. And some of it is also related to how a lot of our customers are designing these inference applications. Like I said before, a chatbot needs a sub-second response, but a batch does not. So you can take an example where you're running a batch inference at scale, and then you're storing that data, and when a request is coming in, you're actually serving it from that store. So there is a lot that is happening in this space, but ultimately, the customer needs are speed and scale, and for that, there is a lot of innovation in this space.
Yeah, it's been fun. I cover more the consumer edge, where humans meet technology is my beat. And I've been working a lot more closely with our analyst, hi Bob, who does the networking side of our practice, because these worlds are kind of coming together through AI and edge and inference all at the same time, where we find ourselves in the same conversation in a really great way, where I'm like, whoa, I didn't realize how critical this piece, like the networking piece of this, was just because I wasn't as in those weeds, but it's been so fun to connect the dots and kind of realize, wait a minute, this the entire infrastructure of everything has to improve to keep up with this acceleration, and that's where all of our collaboration, and honestly why I think GKE is so uniquely poised. I mean, I guess we're sitting here at Google, but I thought this before we were doing this series. Well, you're so uniquely poised to help be the player in the game who helps people build the coolest stuff, because it's built for that, it's designed for that, and it's agile enough. So for the platform engineers who are watching us right now, if you could tell them anything about GKE, or frankly anything that you're working on right now, what would you like them to know? Eddie, I'll start with you.
You're safe. Like like GKE is a safe place,
nice thing to
and
say.
it's the platform.
It is.
And more importantly, it's like, don't be afraid to get into the conversation with the AI engineers and the ML engineers in your organization, and know that we can build a platform that supports not just the regular workloads, but also the major AI workloads. And again, most of these customers who have built large platforms on Kubernetes and on GKE, they've already got those established processes and procedures and DevOps practices and all that stuff. Now you can take that and now bring it into the serving side, which is basically the same thing that they were doing before, again, but now with fancy hardware, right? And lots of storage and lots of networking. And so paradigms change a little bit, but the platform is the most important thing at this point in time, because without a very strong platform, you can train all day, because training fails, you start training again. But if my major enterprise app goes down, we've got problems, right? So the platform and what they've built, it's important. Yeah, it is important. What would you want them all to know?
I want to say that there are lots of buzzwords in the whole AI ML space right now. I want to say that keep an open mind, try the recommended sort of approach that GKE has already written down, do things and learn, and also remember that you can always map what you are doing to the AI ML space. Things like designing a platform, running a platform at scale, production readiness, day 2 operations, SRE. Those things, they don't disappear, right? They just morph a little bit, but the core principles stay the same. So again, all I ask is try the things that we are building. There are labs and tutorials and quick starts. I think the best way that I learn is just by doing. And when you actually do that, you will find that it's not very complicated to build applications with LLMs, inference applications, or even training workloads.
I think that's good advice, and to your point, particularly with Google, but even across the internet, there's a lot of resources.
Yes.
There's this really nice sense of we got to build better together for this one, I feel like, and plus it's so expensive. I'm talking about so much data. It's just a different level of collaboration that I'm seeing across both the industry as well as academia and the government. It's cool. It's a very exciting time, like we're saying. It's a good time to be a nerd. It's a really great time to be a nerd. Well, speaking of, what excites you most about the future of where GKE is going and what your customers are going to be able to build as a result? Eddie, I'll start with you.
Yeah, I mean, I guess the big buzzword I think for me is agentic AI. And the reason being is my background as dev and distributed systems, I really believed in the microservice world prior to AI becoming a big thing. Microservices was a big thing, and Kubernetes was, kind of built around that microservice concept. And if you think about what agentic AI really means, it's about, when we started this whole AI concept and we started shipping applications, they were all monoliths. They were literally like a bunch of Python code in a container that serves, that does everything, and it's one big application. And now with the agentic AI, now we're saying it's like, no, we need to separate these, have different concerns, scale them differently when they need to. I'm calling it microservices 2.0. I'm going to sit out there and put that out there because I think it's really how I can have different agents doing different things at different scales, and then having—
I like that take.
In reality, if you think of the things that we talked about, MCP and the Model Context Protocol and A2A that we just recently gave to the Linux
All the
Foundation.
acronyms we didn't have 6 months
I know,
ago.
Agent-to-agent protocol. What they're basically doing is making it easier for customers who already took this microservice attitude and built applications in this compartmentalized way and say, now I can easily add agents to it, and more importantly, make LLMs aware of my APIs and my applications. So it's really making it so it's easier to innovate and make what we already have better and faster. I think it's going to be really cool.
Yeah, what about you, Poonam? What gets you most stoked?
Just want to say, never a dull moment.
Sitting next to Eddie, or in the Kubernetes?
Well, both. I think this space is so exciting right now. There is a lot going on, and I think it will continue to grow. And this whole pie of AI ML market will continue to grow, and eventually we'll settle down on some sort of architectures or solutions and stuff like that, but I think we're not there yet. There is a lot of innovation that is happening in both inference, for example, distributed inference. We worked with Red Hat and a bunch of other big partners, and launched LLMD for Kubernetes. So that's going to be something that you watch for. And other than distributed inference, I think agentic, like Eddie said, is going to be a big thing, and we are all focusing on that. But this whole space will evolve. For example, it will move from maybe training your, and that's my hypothesis, like you do pre-training today, a lot of pre-training, but that moves into, you just launch an agent and it learns in its environment and by working with other agents in sort of real time. So your training moves from pre-training to, inference and training are happening at the same time, like reinforcement learning.
Yeah.
So it's a very exciting space, and there is a lot that is happening right now. So,
all right. So last question for you both. What do you hope this next technological era, we don't just have to call it AI, because I think we'll stop using this term in a while and things will just be operating differently in the same way we did with compute and laptops, for example. What do you hope this next technological revolution does for the people that you love and you care about outside of our little nerd fam? I'll start with you.
I'll give you one example. Like I was planning a family trip to Lake Tahoe last
beautiful
month.
place.
And usually when I do something like that, I have to do a bunch of research beforehand, Google stuff, and
lots of tabs open. If you're like me, there's 37 different tabs where I'm going in between different hikes and routes, and
yeah. And I have kids, and I have to take that into consideration, as well as other sort of activities that they really want to do. And this time I just went to Gemini and I said, hey, I'm planning a trip from this date to this date, Lake Tahoe. I'm going to pick a rental car from San Francisco, and then I'm going to drive. Can you please just create an itinerary? And it just did it. And it took me less than a minute.
Amazing.
All I did is I took a picture of it, and I did exactly I think 80 to 90% I did the same thing. So our lives are changing, and I think in a good way. one last example, like my 9-year-old son.
These are great. I love this. This is why I asked the question. This is usually where we get the best answers.
So I'm working, and my 9-year-old son walks into my office, and he's working on this, reading comprehension, and says, "I need more passages like this to practice." And usually it's something that you will start working on, and it will take you hours. You will figure out what to buy, which book to purchase, and all that. I went to Gemini and I asked, "Hey, can you generate like passages for like 9-year-old and some questions with some answers that I can later compare his answers to?" And it was done in minutes. And I just printed that, gave it to my son, and
That's cool.
off you go. So
it's honestly just a couple seconds. I was using Gemini. This is an Ed story. I was using Gemini in the car driving from Chicago to Des Moines with my boyfriend who's studying for his level 3 Master Somm test. And I mean, I'm not the best person to quiz him. I love wine, but I am not at that level. And though maybe someday, you never know. But I was able to do exactly what you said. I was able to feed in questions, sample questions they have on the test, and then have him build them out different quizzes about different sections, different wine regions, different cocktails and aperitifs. And it was so fun, particularly to watch someone who's not as much of he's a wine nerd, but he's not a nerd like we are in Techlandia, but to watch him get so excited about the tool, to see what was possible. And he's like, "Oh my God, I'm going to show all my other Somm friends, and I'm going to show the restaurant, and I'm going to do all this stuff." And we don't always get to, but they're so nice when we do. I got to see that light bulb moment when all of a sudden everything changes.
Yeah.
And even for you as a parent, being able to do that so much faster and easier, it's not like you have time to be doing your day job in the car on the way home, writing out questions for him. It's you need these tools they don't have to, but they can make us much better and more efficient versions of ourselves.
That's right.
Which is very cool. What about you, Eddie? What do you hope it all does for the
My
people
story
you
is
love?
very similar, actually. I was asked to speak at my daughter. She was in kindergarten last school year. She was in kindergarten, and they did a career fair. And I'm like, I got to talk to kindergarten about AI and Kubernetes. How am I going to do that?
Love this challenge, though. Living for this. Want to be a fly on the wall. Really
So
bad.
I got in there, and what I did was I created a gem on Gemini, and I pre-trained it and told it, like, "Hey, I want you to you're speaking to a group of 5-year-olds at an elementary school. The name of the elementary school, their mascot, everything." And then I walked in there, and then I used the Gemini, and I put it on the screen, and I put the microphone on, and each kid came in with a story that, like, so let's build a story together. And then I started the story. I want to make a story about a little tiger, because the Dripping Springs Tiger, that's where I live in Texas. And he's starting in kindergarten, and he wants to learn what he wants to do for a career. And then each kid came up, and we used the microphone, and they talked into Gemini
He's
to
an
feed in the rest.
NLP, baby. I love it.
And it created a whole entire story, and it created a picture of the little tiger with the backpack on at a school, and using our VO model. And I had a little kid in the back. He was wearing an astronaut suit, because all the kids were wearing what they want to be when they grow up. And he said, "I want to change my job. I want to be an AI engineer."
Okay, I just got goosebumps.
Yeah.
I just felt that straight in my soul. I mean, I love astronauts too.
But I want to make sure, like, people understand, like, this is a way for
high
us to be smarter.
High school wasn't too early.
Yeah.
Oh my gosh. Oh, I love that. How good did that make you feel?
It's the best feeling.
Did you have a little cry in the car?
At the end of the day, I was like, I still talk to him. I run into his parents at the coffee shop. We have a very small town. I run into his parents in the coffee shop. I'm like, "He keeps talking about your AI talk." I'm like, "Yeah, okay." So it was really cool. Yeah. So as long as the next generation understands that it's going to be different. There's no lie. It's not going to be different. It's already starting to see different. But it's what we do to adapt to it, and where we can take ourselves, and then be part of it instead of being in it, right? Like, it's like, hey, be part of it, build it, and don't just let it happen to you.
Yeah, I think that's great advice for just about everything.
Yeah, that's true.
This was great. Poonam, Eddie, thank you so much.
Thank you.
One of my favorite conversations of the series. I'm not
you.
supposed to pick a favorite child, but this was really good. And we killed the food analogies, everything. I wasn't kidding, but truly, this was a blast. Appreciate you both flying in.
Thank you so much.
you,
It was an
Savannah.
awesome experience. Thank you.
And thank all of you for tuning in to this super awesome, absolutely rad, I bet you're not watching anything cooler series that we have here, Google Passport to Containers. My name's Savannah Peterson. You're watching theCUBE, the leading source for enterprise tech news.